And we're coming to the very, very last quarter of an hour. That's a summary of today's talks. Your feedback, your ideas for the next year, my comments on what's going on, my insights, your insights. And since I have the privilege to hold this microphone, I would just like to give you some ideas, what I've seen in the past year, what I think, how we can summarize this entire event and this entire development. I made up a sketch of about 4 big blocks. These 4 blocks, the first block is the field of SDR. What have we seen? We have seen a further maturity, a grown maturity of GNU Radio, a greater role of GNU Radio. It has acquired a very central role. It's a door opener for all those who want to go into, who want to acquire, who want to go into this new field and learn how to do things. So it is a great learning platform, but it's not just a learning platform, but it has also become a very powerful and recognized platform. So the reason why we've seen also Rohde & Schwarz today here is closely connected to GNU Radio. And it's very interesting that such a big company who's very, very established in the market, who's very widely known for all sorts of everything radio, is dealing with GNU Radio and bringing it on. There is a reason why Rohde & Schwarz is doing it. So the field of SDR is broadening, is widening, is deepening. We have seen lots of new devices. We of course, most of us have seen the RTL SDR stick and all those little cheap devices and so on. But this is already so common that we don't even think about it as the big revolution. But of course it is part of a revolution. It's the basis of the revolution, the availability of those cheap devices. We see that radio is getting much cheaper, much cheaper. We see those Boa-Feng devices, which are in its core SDR devices. They're quite good in the meantime. Maybe they're not so perfect as some of us may expect it, but they're quite good, and they're drawing the price level very much to the bottom. And they're bringing radio devices to everyone. So this is about the field. I have one block about the future, because I have had the honor to read a presentation developed by Ulrich Rohde, but I will give you a short glimpse of it. Ulrich Rohde, Professor Rohde, is writing about what we've seen, systems on chip. The Zinc is one very recent development, but he's proposing that we will also see the radio on chip, a device which is a radio, which is an integrated circuit. And this, of course, brings a lot of new developments and a lot of new possibilities. We've seen ubiquitous computing. The next step is, of course, ubiquitous radio. Every device can be a radio. Everything can be a radio. And everything can interact with high frequency. So this is just one insight, but I will talk about this in the end of that, in the fourth block. The second thing is the community. This community is really maturing. We're seeing it also with this event. We're seeing it with growing participation numbers. At FOSDEM, the SDR track, here in this track, we've exceeded the record of last year. There have been about 20 to 30% more people this year here in this event than last year. And last year has already grown to 2 years before. So we're seeing a growth in this community. We're seeing more participation from universities. Universities come here. And something many speakers, including you just before, have mentioned, we have to cooperate. And I'd also like to quote Erwin Rau, who pointed out the tremendous power we can have as a community when we cooperate. This community is very much similar to the Linux community. Think of how many Linux devices are out there. There are, I guess, 3 to 4 times as many Linux devices out there in the world than we have Windows devices. Count the desktop, the set-top boxes, the routers, the Fritz boxes here in Germany, all those little devices. Count the Android phones. All of this development would not have been possible without the creation of a community of developers who have created the Linux kernel and everything around. So we have the opportunity to create something similar as a community, as a radio community, as a worldwide software radio development community. And there are things possible which we cannot think about today because we cannot figure out what's possible in the future. About the event, I've made up my mind about this event. It's the 3rd time we're here, and last year we thought, okay, we're here to stay. This time, we're not even here to stay, but we know we have reached a good reputation. We have speakers from all around the world. We have a good recognition as a forum and as an appreciated forum by many who come here and share their ideas, meet up, later on drink 1, 2, 3 many beers together, and socialize and create ideas and share ideas and maybe sit somewhere in the city center of Friedrichshafen and think about how many funny ideas could be implemented until next year. There was one goal why we set up this event 3 years ago, Michael Hartje and I. We thought, well, there was this big amateur radio community on the one hand side, and there was the academia and the industry on the other hand side. And there was not very much interaction and not very much communication. And we wanted those parties to communicate. We wanted those parties to interact, to exchange ideas. And particularly we wanted professional companies to come here and contact radio amateurs and take a lot of input from this community, because amateur radio is not just those old devices, tubes and all those things, which it is, of course, but it is also about innovation. It's also about bridging, creating bridges to state-of-the-art technology. And we wanted to create a forum, a marketplace of ideas, how to talk to each other about this bridging, you know? I hope you understand me. We felt that this kind of bridge between the big amateur radio community, the legacy, the old amateur radio community, and the software fields, this didn't exist, and there was a definite need to create such a bridge. And we have it here. We didn't see this event as a competition to FOSDEM. We had 2 speeches at FOSDEM a couple of years ago, and in the beginning this morning I asked the audience how many radio amateurs were there in the audience, and I thought about, well, maybe 10 out of 100. But I was wrong. There were about 70%, 70 people raised their hands. this was a really overwhelming moment to me because I understood, okay, these are our guys. These are people who understand about radio. They are in the software field, but they understand about radio. But nevertheless, the FOSDEM is a software conference. It's quite difficult compared to the entity of FOSDEM, where the FOSDEM is a meetup place for software engineers. They have kind of difficulties to understand radio. So we said, yeah, let's create a meeting point for software engineers within the radio guys, within the radio community. And there is no better place than Friedrichshafen, because here are the radio guys. And it's a good place to teach radio guys how to understand software and software signal processing. So this is from where we've come, and this is where we stand now. And now I'd like to share some thoughts about the future. And the interesting thing is this presentation from Ulrich Rode, who wrote about radio on chip. Who of you has disassembled a patch antenna, a Wi-Fi patch antenna? One person, 2, 3, 4? Okay. For the rest of you, do it. Very interesting. Because, you know, I'm also a trainer for license classes, and what we teach people is those linear antennas, those dipole types. A patch antenna is not a dipole type. It's a two-dimensional thing. It's a PCB, it's a board, and there are patches, and they're arranged 40, 50 little patches, depending on the size, and they're just next to each other. So there are no more stretched dipoles. But it's like quad antennas, but with filled up spaces. And the edges are the things that really transmit. And the interesting thing about those antennas is that they're actually array antennas. It's like a radar array, the directional antennas, and figure out what we're doing with phase shifting, with computational phase shifting already now in our signal processing chains. You can do all those things with multiple inputs. Let's say you have multiple receivers, multiple radios on chip, and they all produce an IQ stream. And you can do phase shifting in any way you want. You can create multi-beams. You can create antennas that pinpoint their sensitivity in different directions. They can scan the environment, and this is where things become really interesting. Antennas that can scan the environment, that can be directional towards the environment and change their sensitivity schemes just by software, in the according speed of software. This then means that radio will become a quasi-optical discipline. It will become a discipline, of course, a communication discipline, but it will be enriched with an optical and orientation part. Just with radar, which we have already today, which is my business field, we have big radars, 25 kilowatts, pointing into one direction, turning antennas and so on. This is old school stuff. It's not modern. What's modern is, in the moment, arrays, but what's the future is antennas that don't move anymore and that have completely dynamic reception and transmission characteristics. And this will be possible with radios on chip. And this is the direction which I see where we're going, but this is just one little perspective because it's my personal professional field. So this is how I perceive this development, and I would summarize it as we're in the center of a perfect storm. Everything is changing, and we have the key to the future because we know what's possible. So These are my ideas. I want to hand over the microphone to you guys. Many of you, of course, all of you all have your own ideas about this field. And maybe you want to share those ideas here in the forum, but also maybe you want to share your ideas with a beer later on. Who wants to have the microphone?
The two winners have to take their modules.
Okay. Who are the winners?
The two who had the questions.
Okay, two guys with a question. Okay, any more comments? No comments?
Yeah, well, many of the good things we saw today were also dependent on analog hardware, of course. There's also, well, there's a limited amount of suppliers for this analog hardware because you cannot build everything out of discrete FETs. For example, you want to make a modulator for very high frequency, well, you really have to make it integrated in one piece of silicon. But also people that are actually designing those chips in this community.
Well, I haven't seen people designing chips, but we've seen the FPGA presentation today. I think this is of increasing importance. Definitely, you can do so many things with an FPGA, and I think there is also one tendency we see already with FPGAs. That's big data. Because parallelization of data processing is actually the big technology that's behind big data. And we're doing that in a small scale with FPGAs. And also very interesting is actually the idea shared by Janos today. Without knowing, I would say it's kind of a microservices architecture for IQ streams. And it's about parallelizing IQ processing. And if we have kind of that, it's a blending between big data and microservices with a special focus on IQ data. That's what I would say here. Very interesting.
Actually, I have some comment to your ideas, this beam steering things. I think for practical purposes, it's today you could do it with without a radio on a chip, okay? Even with today SDR hardwares. Actually, I am thinking about producing beam steering for some moon bouncing experiment, okay? It's feasible, for example, to make an array 16 transmitter, 16 antennas, okay, and to make some SDR software which do this phase shifting. And even in my last professional work, we produced such an equipment for satellites, okay, steering the transmitter and receiver beams, okay, for low orbit satellites, always contacting with a special geosynchronous satellites. In that case, you continuously have to steer the beam, okay? And with 16 receiver and 16 transmitter, we could do it with today's technology. So your dreams is completely feasible in it.
That's really good news. So, okay, any more comments?
I think antenna steering could be a solution for the upcoming noise on the bands. And if we have some intelligent reactions, we could make something like noise blanking, or blanking or minimizing the amplitudes of man-made noise, especially today's changes in the smart home with a lot of intelligent processors and the voltage regulators. That could be a solution if we had an idea to make it intelligent. If you don't know the direction, you can give the task to the machine.
One comment to this, okay? The beam steering is one thing, okay, and noise cancellation is another thing, okay? For the beam steering, you maximize the power or the sensitivity into one direction, okay? For noise cancellation, okay, use a different techniques. If you have n antenna, in that case, you could have in n-1 direction to minimize the sensitivity. Okay, that's a little bit different optimization. So we should know that it's a different techniques. You could do it, okay, but it's different from the beam steering.
Yeah, maybe the idea which is a bit more application level, because well, there's many QSL reports, and actually matching QSL reports with actual total electron count in the atmosphere, and actually making maps of that. That might be also interesting big data application for ham radio.
Yeah, this is just one interesting application, but I'd like to share some ideas about, well, there is a project about a whisper beacon on the Neumayer 3 station in Antarctica, which is going to be deployed later this year. And the background of this project is that not so much is known about propagation over the poles, because the magnetic lines, magnetic field lines, they don't go more or less parallel to the Earth surface, but they go orthogonal to the Earth surface. And the idea behind this project, which is financed by the German Amateur Radio Club, the ARC, together with the Alfred Wegener Institute in Bremen, who are running the Neumayer 3 station. It's going to be a whisper beacon, and Michael Hartje is also involved in this project because he is in Bremen and he's doing a lot of things about whisper. Well, the idea is to record data, and he's doing that already now. To record data about propagation possibilities and how things work, particularly with QSOs which are cross-polar. Because you can, of course, detect when a QSO goes cross-polar, and the question is, how good are those propagation, how good is this quality, the transmission quality? So definitely there is some research going on in this area. Okay, first people are leaving. I'd like to say my last words. Last words are words of thank you, you all who have made this conference a great success. I would like to thank my colleague who's not here, Michael Hartje. I would like to thank the Forum of Three Michaels, Michael Hartje, Mike Mechtel, and Michael Niemitz, three professors who are sharing ideas, who are supporting us, who are creating motivation, who give us the notion that things are important or in which direction we should go. I'd also like to say thank you to Ulrich Rode, who has sponsored this event, who has made it possible, that we can record all those talks on video and put all those talks on our YouTube channel. I'd like to say thank you also to the organizers of the Deutsche Amateur Radio Club, who have given us this location and who are granting us the possibility to do it here. Without the DRC, this would not be possible, of course. So, I hope I've not forgotten anyone. Yeah, the speakers, of course, the speakers. Our speakers are our greatest asset. They're your asset. You are the SDRA. The speakers and the audience together. This is the SDRA. Thank you very much. Thanks for coming. And I hope to see you and even more of you next year again. Thank you.